Hello, Aslam class. Today's date is Monday, the 8th of February. Now, just to let you know, the video that you're about to watch was actually recorded for Friday, which is why the date on the slides read the 5th of February. Of course, on Friday, you had a no-screen afternoon, so we're moving the video that you would have normally seen on a Friday afternoon. We're pushing that over to today. So the video you're about to see was actually shot for Friday. That's why the date is different, but it's absolutely fine. You can watch that video now for today's lesson, and then we'll pick it up as the week goes on. All right, then, guys, hope that's clear, and enjoy the lesson. Hi, Aslam class. Welcome to your maths lesson, which is on the 5th of the 2nd of February, 2021. Okay, this week we've been looking a lot at fractions, and in fact we've been looking at equivalent fractions all week. Monday, Tuesday, Wednesday, and Thursday we were looking at equivalent fractions, and it's been really good to see on Tapestry, and when I was in school yesterday, on Wednesday as well, it was really good to see how well everyone is doing with equivalent fractions. They are tricky and they can be quite difficult. However, I think everyone's done a really good job. And if you still don't get it, then obviously in our live sessions from today, please bring it up. I will be going over equivalence fractions with you guys again in that session. But also, you've got the what should I say, the advantage of being able to look back at the videos whenever you want. So if you're still not 100% sure, my advice to you is to go and have a look at the maths videos that we've done on equivalent fractions this week, so you can go over it again and again and again until you kind of do get it, I suppose. But it is great. I know that some of you have found it quite difficult, but majority of you are now on track and doing really well with it. So you'll be pleased to know we're moving away from kind of equivalent fractions today, but we're still doing fractions. We're not getting away from that just yet. But of course, as always, we start our maths lessons with some arithmetic questions. So here are your arithmetic questions for today. We have 10 questions. All you need to do is pause the video and then we go through the answers together in a moment. So pause the video. Hopefully that gives you enough time so we can go through the answers. So I'm going to stop sharing the screen so you can see what I'm doing on the board. It'll be a lot clearer that way for you. And also I get to see the questions as well. So question number 1 is 3 times 3, our 3 times table. Question number 1 is, the answer is 9. Question number 2, we have to add these two values together. So 1,345 plus 3,333. Let's add the thousands together first and we get 4,000. Let's add the hundreds together, we then get 600. Let's add the tens together, we then get 70. And then let's add the ones together and we get 8. So 4,678. Today's date is Roman numeral. It's the 5th, so that's 5 of the 2nd month. 2000 is 2m, 21, 2x, 1. So there we go, V2MMXXI. What is the number in the sequence? The next number, so we go 45 and then we go to 41. We then go to 37, we then go to 33. It's going down in 4s, so our next number is 29. The question 5, 9 times 7 is 63. We then go up here, question 6, 64 divided by 4 is 16. And then we've got some measuring questions. What is 500 millimeters in centimeters? There are 10 millimeters to every centimeter, but centimeter is a larger distance. So, well, it's the same, but the value is less. So we divide 500 by 10. So 500 millimeters is actually 50 centimeters. And what is 3,000 meters in kilometers? Again, kilometers is the higher unit. So, and there are 1,000 meters to every 1 kilometer. So we do 3,000 divided by 1,000, and that will give us 3 kilometers. Question 9, on a 24-hour clock, what is 9:20 p.m.? It's 21 hours and 20 minutes. And then the last question, 54 divided by 6 is 9. So there you go, well done if you got all of them questions correct, which I'm sure you did. And let's go back to sharing the screen so you can see today's work. Okay, today we're going to be looking at fractions that are greater than 1 whole. Because we can, believe it or not, just to quickly show you, all numbers that are greater than 1 are a fraction. Okay, we can have, I mean, if I take the number 4, for instance, okay, I can write 4 as a fraction as 4 over 1. And that basically means that my whole was only split into 1 part. So that's always 1 whole. And I've got 4 of them. So 4 can also be, all numbers can be expressed as a fraction over 1, as long as they're whole. Just a little tip. Okay. So just for a recap, what I would like you to do is spend about 2 minutes in using these digit cards to make groups of fractions that are equivalent. And how many equivalent fractions can you find? So for example, let's take 1 and 4. Okay, they're the 2 cards that I'm going to use to begin with. All right. And then I have a look and I go, right, what other numbers can I use then to show that's equivalent? Okay, with these cards in front of me. All right. So have a little think about it, which ones are equivalent, and then I may go, right, okay, here we go. 4. I know that 2/8 is also the equivalent to 1/4, because I know if I times 1 by 2, I get 2, and if I times 4 by 2, I get 8 as well. It's just another way of working it out. So give it a go, see how many you can get in 2 minutes. And when you put that up on the tapestry, I'll have a look at that. I won't go through now with the video, otherwise the video will last for about half an hour, and that won't give you any time to do any work. So hopefully you're given that a good opportunity. Put it onto tapestry so I can have a look. Okay, today we're going to be looking at what happens to a fraction that are greater than 1 whole. And you can see in this picture here, we've got a part whole model that is showing us what we do with fractions once they go above that 1 whole. So here you can see we've got our fraction 7 over 4. That is telling us that we've already, because we've gone over 1 whole, which would be 4 over 4, that tells us that we filled up 1 whole, haven't we? And you can see it in the picture here. Our bar that is split into 4, because the denominator is 4, we can see that we've got 1 bar that is completely full. Okay, so now we're going greater than 1 whole, aren't we now? Because we're now starting our new bar that is split into 4 and to make up the 7 shaded parts. Because we can't colour in 7 if we've only got 4 there. So that tells us that we've completed 1 whole. Let's move on to the next one. So here we've got a fraction that is 7 over 4. 7 shaded parts that have gone into holes that have been split into 4. We know that one of them is full. So therefore, how many have we got shaded in our fourth bar, in our full bar? There are 4 shaded in. So we know that 1 whole here is 4 out of 4. This fraction here, we've only got 3 shaded out of 4. So therefore we add the 2 together. 4 of our whole, and then 3 more of our next whole, we get 7. So in this diagram, if we were to talk about it, there are 8 quarters in the diagram. 4 quarters make 1 whole. So 4 quarters equals 1 whole, and 7 quarters equals 1 whole and 3 quarters. And hopefully you're able to see that there. We've got 1 whole and 3 quarters. So let's have a look at this one and let's go through it, and I'll put it up on the board as well over here so we can see what we're doing. Okay, so here we've got our part whole model, and how are we going to split this fraction up so we can find out how we write this fraction out. So we can see here in our model if I draw my bars at the top here, 1, 2, 3 equal bars, and they are split into 5s. 1, 2, 3, 4. Let's just add another one on the end, make it easier. So we got 5. We have this is shaded in. And then we've got 3 shaded in at the bottom. Okay. Now, we've made our part-whole model. Now let's have a look. How are we going to break this one up? Well, first of all, how many parts are there in each bar? What have we divided our wholes into here? And let's count. We've got 1, 2, 3, 4, 5. That is the same for all of the bars here, isn't it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we divided our bars up into 5s, into fifths. How do we? Where do we put that on our fraction? That represents the denominator. So our denominator is going to be out of 5. Every whole has been split into 5 pieces, into fifths. Okay. In total, we have 15 fifths in this diagram. How many of them have been shaded? That's what we're going to move on to. We count. So we need to work out how many have been shaded. We've got 5, 5, add the 3, 13. So this is showing us 13 over 5. All right. Now let's break this up even more. How many of these are whole? So in our picture, our 2 bars are whole. Now the bars are made out of 5s. And how many have we got shaded in there? We've got 10. Yeah. In the next one, which isn't whole, we've got our bar 1, 2, 3, 4, 5, and 3 of them are shaded in. So that's 3 out of 5. Notice when we go over a whole, the numerator will always be bigger than the denominator. And that is telling us that we have wholes that are in 5 groups, and we've got 13 of them. We've got 13 fifths. All right. So when we go above a whole, we can still use fractions, but this is what we call an improper fraction because the denominator, the value of the denominator is less than the numerator. And that's because we've gone over 1. Hopefully that makes sense. So I would like you now to give it a go. Okay, so if you can please complete the part-whole diagrams to answer these questions. So in the first question, part A here, all you need to do is fill in what the fractions are, and then over here we do the same. So what are 9 fifths the same as? How else can we say what 9 fifths are? What's it made up of? And how many quarters are the same as 2 wholes and 1 quarter? So give it a go and let's see how you do. Okay, welcome back. Hopefully you paused the video and we go through the answers. So here, let's start at the bottom here. We have our bar and it is split into 5 parts. That means our denominator is going to be 5, isn't it? But how many of them are shaded in? Let's see. 1, 2, 3, 4, 5. So we know that 5 over 5, that is equal to 1 whole because our whole bar has been colored in. Then we go over to this one here. How many bars, how many have we split it into? Divided it by 5. So our denominator is going to be 5. How many will our numerator be? Only 4 have been shaded in. So we've got 4 over 5. When we combine the 2 together, we get this up here. We've got 1 whole and we're adding on 4 other fifths. In total, we have 9 fifths that are shaded in. Therefore, our fraction is going to be 9 over 5. So well done if you got that one correct. Let's go over to this one here. Over here first, we've got our bars and they've been split into quarters, into 4s. And here we've got 2 whole quarters. Okay, we've got 2 wholes made up of quarters. There are 8 quarters here all together, but our denominator is going to be 4 because that's what we've divided the bars up into. So you should have 8/4, which is 2 wholes. Over here, we've got 1 bar shaded in out of 4, so that's 1/4. Now we combine the two together. We've got 2 wholes and we've got 1 4 here, okay? In total, we have 12 quarters, all right? But our denominator is going to be 4 because that's what we divided the bars into. Out of them 12 quarters, only 9 have been shaded in. Therefore, it's 9/4. And that tells us that we've got 2 wholes and then 1/4 remaining. So well done if you got them correct. Now, we can also draw part whole models to write sentences to describe the fraction. So here we've got, just to recap, we've got two bars that have been cut into 6s, and so we know that in total we have, in this picture here, we have 12 parts, okay? 12 parts, 2 lots of 6s. Now, here though, it says we've got 14 that are 14/6, okay? So we need to think about this. Over here, we got 12/6. And over here, we've only got 2/6. We put 2 together, we get 14/6. There should be another bar here. I don't know why that's not in there, okay? But what we can do is we can think about what this is actually equivalent to, okay? So instead of doing 1 for 14/6, let's see what is actually equivalent to. So bear with me 1 second. If I was to divide this whole number by 2, okay, what would my denominator be? It would be 3, okay? So if I divided that by 3, there's my bar of 3, okay? Sorry, divided by 2, I would get that, okay? Now, bear with me 1 second. So our denominator will be 3. If I divide 14 by 2, I will get 7. So 7/3 is actually an equivalent to 14/6. All right. And then what I do is, okay, I need to shade in my 7. 1, 2, 3, 4, 5, 6. Need to have another group of 3, so I can shade in that last one. 7. So that is an equivalent fraction to 14/6. If I was to split this up, I would have 2 bars that are full, that have been split into 3s, and that would be 6/3, and then I would have 1 bar that would just be coloured in, and that would be my 1/3. So you can see 1/3 plus 6/3 is 7/3. Let me just make that bigger for you so you can see that. Now, when we have a look at our total here, we still got 2 full bars, and a bar here. But because we divided this whole fraction by 2, this is now equivalent. We're now doing it in thirds rather than sixths, so this is equivalent, okay? So that's what that means. So there is our fraction, 14/6. Find an equivalent fraction for that, and you can easily do that by dividing them 2 numbers by 2, can't we? And then we can draw a new part whole model showing an equivalent fraction to 14/6. So that would be 7/3. Hopefully that makes sense. I think. Now, here we have a reasoning problem. Okay, reasoning problems come up quite often. So Jessica says, it is impossible for me to have more than 4 quarters of pizza, as a quarter is a pizza split into 4. Do you agree with Jessica? Explain your answer to a partner, or explain it to someone, and then sketch a picture to help you explain what you mean. So you can pause the video and have a think about this. Is she correct? So it's impossible for her to have more than 4/4 of a pizza. I disagree with her, because when I have a pizza, I maybe have 2 pizzas and I can cut both of them into quarters and I have 8 quarters in total. So I could eat 6/4 of pizza if I wanted to. It would just mean that I would eat 1 whole pizza before I get onto that next one. So she is not correct. It is possible to have more than 4/4 of pizza, as because you can go over 1 whole. And a picture to explain that could be simply this. Here are my pizzas, okay, and my cheesy pizzas, yum, yum, yum. And what I'm going to do is I'm going to shade in the ones that I eat. So I open up the box and I eat that slice. I then eat this slice. I then eat this slice, and then I then eat this slice. How many quarters have I eaten? I've eaten 4/4 so far. I'm still feeling a bit peckish, so I go over to my new pizza, my next pizza, and yum, 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 yum. I have another 1/4 of a pizza there. Oh, I'm going to have another 1/4 slice there. Oh, and I'd maybe just be able to fit in 1 more. Oh, I'm bursting at the seams here. There is my final piece of pizza that I've eaten. So in total, I've eaten 7/4 there. So it is possible to eat more than 4/4 of pizza, okay? Because my pizzas have been split into quarters there, and you can clearly see that I've coloured in 7/4 of pizza. I don't recommend that you eat that much of pizza. Very filling. Okay, so here's your independent work for today. All you need to do is complete the sentences for part A, okay? So you need to fill in the boxes there. For question 2, you shade in the bar models to represent the fractions that you see in the number sentences. For these 3, you just need to complete the statements, and then for your real big challenge, here is your final challenge. You can pause the video and you can answer them questions, please. Okay, we're going to go through the answers very quickly. So let's have a look. There are 7/5 altogether, and we can see that in the picture. We've got 2 bars that are split into fifths, 7 are shaded in. So 7/5 is equal to, how many holes do we have here? We have 1. And how many fifths do we have left over? We have 2. So 1 whole and 2 fifths. Question 2, shade the bar models to represent the fractions. So we've got 5/3. So we've got our bar models, they've been split into 3. We need to shade in 5 of them because that's what the numerator is saying. So we shade in 1, 2, 3, 4, 5. So 3/5, we can see we've got 1 whole and 2 thirds. So as our fraction, okay, we get 5/3. Now we can write this as 1 whole and then 2/3. That's called a mixed number, and we can look at that later on. You don't have to worry about that now. Right, question 3, complete the statements. How many holes do we have here? So our fraction here is split into 2. So how many 2s can we fit into 12, okay, to give us our holes? And if you imagine it, we've got 2, so that's 1 hole, another 2, that's 4, another 2, that's 6, another 2, that's 8, another 2, that's 10, another 2, that's 12. We've counted 2 6 times, so we've got 6 holes in total. Okay, let's look at B. Our denominator is 4, so we're now looking at groups of 4, okay? So we look at our first group of 4, that's 1 whole. Add another 4, that's 2 whole. That's 8 parts we've now had. Add another whole, okay, that will be 12 parts that we've got. So there are 3 holes in total. For C, again, we've been split into 4 parts. So 1 whole is equal to 4 parts. Another whole would be 8 parts. Another whole would be 12. Now, if we added up another whole, we would go over 15. Okay, so we can't add on another whole, so we can only add on 3 holes, which takes us to 12. And then how many do we add on to 12 to get to 15? 3. So we've got 3 quarters left. And then for this one here, 2 holes, we've got 2 parts. Our bar has been split into 2 parts. So if we had 7, we would get 14 parts, 7 holes, and 1/2 remaining. For the last question, question 4, Whitney bakes 26 muffins. Muffins are packed into boxes of 4. How many boxes can Whitney fill? Okay, so again, let's, you think about it in the diagram. You've got 4, you've got bars that are split into 4. You need to shade in 26 of them. You would be able to shade in 6 full bars. So she can actually pack 6 boxes full. The last box won't be full because there'll be 2 left over. Right, guys, I hope that helps. I hope you found that lesson okay, but if you've got any questions, leave a message onto Teams and I'll get back to you as soon as I can. See you in the next video, guys. Have a good weekend. Bye-bye.